Let's take a look at example 4.4.7. Let event C equal taking an English class. Let event D equal taking a speech class. Suppose the probability of C is 0.75, the probability of D is 0.3, the probability of C given D is 0.75, and the probability of C and D is 0.225. We have to justify our answers to the following questions numerically, so we want to make sure we use the correct formulas to show independence and mutual exclusivity. For independence, we want to show that the probability of C and D is equal to the probability of C times the probability of D. So if we can show this relationship, we have independence. Or the probability of C given D equals the probability of C, or D given C is the probability of D. Any one of these three we can show independence with. But we don't know what the probability of D given C is. So we cannot use that for this particular part. We could calculate it. We're actually being asked to calculate it in part C, but we're going to use what we have available to us more easily in order to determine independence. It turns out that this second equation is the easiest one to show. Check out our given information up here. Probability of C given D is 0.75, and the probability of C is 0.75. Since they're equal, C and D are independent, just from that simple comparison. If we wanted to show the first bullet, and again, we only have to show one of these three, but if we wanted to show the first one, we could multiply together C times D, probability of C, 0.75, times the probability of D, 0.3. Multiplying those two together, we would end up with 0.225, which is the probability of C and D. Again, indicating that independence. So yes, C and D are independent. For part B, we want to find out if C and D are mutually exclusive. For sets to be mutually exclusive, they have to have nothing in common. Or if we're looking at their intersection, the probability of the intersection is 0. Above, we're given the probability of C and D is 0.225, which is absolutely not 0. Since the probability of the intersection is not 0, C and D are not mutually exclusive. For the last question, what is the probability of D given C? We're going to use our formula for a given probability. The probability of D given C is the probability of C and D divided by the probability of C. Again, reminding you that that second set, the probability goes in the denominator. We have these numbers. C and D probability is 0.225. Probability of C is 0.75. If we divide those two, we'll end up with 0.3, which is actually the probability of D above, which also implies independence, which we already knew from part A that they were independent.